Hello, how is it going? Gennaro Washington here, CEO of Cortex Solution, and I'm your lead instructor. We're going to be talking about cybersecurity architecture, brought to you by ACSMI. Well, let's get started, shall we? Let's talk about the architecture of cybersecurity. Think about it as the blueprint. For all my cloud IAM people out there, you're going to like this. Now, it's the backbone, in a sense, of any type of strategy that an organization is going to put into place. Because we have a structured framework where we're looking to identify any vulnerabilities, enable any security controls, where they're talking about logical, right, administrative, operational, and we're all about managing risk. Now, with our field becoming ever evolving, and there's always something new around the corner with evolving threats, we want to be sure that we have the dynamic architecture to best address this. But not only that conventional sense, but also we're going to be anticipating new challenges like zero-day threats, right? Any new vulnerabilities that are out there, any supply chain attacks. Now, the core components of pretty much just the architecture itself, think about it like this. We have our access control mechanisms. We talked about what access control is, where we're looking to enforce some form of, policy, procedure, control, whether that being through role-based, attribute-based. And some of the ways we go about doing this are going to be the use of firewalls, encryption. We talked about next gen as well too. Yes, our firewalls are the first line of defense, but now we can do a little bit more. Right? Now we can do more as far as like deep packet inspection, like we talked about, or application layer filtering. We talked about application layer. Remember the OSI model, and utilize encryption, AES 256, RSA. But all in all, these are the core components of the architecture of cybersecurity, which brings us back to the principles for even designing a secure system, which is going to be the CIA triad: confidentiality, integrity, and availability. All in all, knowing that that's the principles of cybersecurity, now we're going to add on the zero trust, where we're not going to trust any device, right, that comes in contact with it. No, we want to be able to continually verify and provide strict access policies. And then we want to layer our defenses in depth. We are adding on different layers of security, adding on your IPS and IDS, adding on everything that you would need in order to make it sound more secure with our security threats or our security posture. Threat modeling comes into play. You've probably not heard of STRIDE, spoofing, tampering, repudiation, information disclosure, denial of service. All we're saying here is that these are just ways we can look and basically go through the process of modeling what threats could potentially be. It's a way for us to identify vulnerabilities, right, in our systems or our networks before they're even exploited. Let's talk about the SSDLC, right? The Secure Software Development Lifecycle. Now, we talked about once before with the IoT devices that we wanted to do security in design, or by design, right? But we're saying we want to have it baked in, not bolted on. Think about it like this. If you want to utilize the tools of creating an application, you want to also be able to test this application, whether that be statically or dynamically. And some examples of that, let's say we incorporate code reviews, right? Automated testing. These are just ways you can do this. Because at every stage of software development, we have to make sure that security is integrated, right? Not an afterthought. Not anymore. No way can security be an afterthought. No, we have to be at the forefront, at the beginning. Which brings me to incident response and recovery. The architecture is going to include different frameworks of IRP, how we can identify. Think about to our NIST CSF, right? And then you want to put into place a whole framework that's going to outline preparation, detection, how can we contain and eradicate these viruses or ransomware that come and take hold of our systems. Now, an example is going to be, if we wanted to secure a financial institution, we know that our sole goal is to protect data, specifically customer data, and prevent fraud if we're looking at it from a financial institution standpoint. So we want to utilize any form of encryption, especially advanced, to secure that payment transaction. We talked about blockchain as well too. We talked about the use of AES, right? RSA. But these are all just ways you can go about doing this. ECC too. Now, think about it like this. If we want to enforce multi-factor authentication for our banking logins, we want to implement behavior analytics to identify anomalies. well, what best way to do that than to deploy IDSs and IPSs and web application firewalls? And there you go, right? Because we can block and actually see that there's a phishing attack, potentially phishing attack going on. We can do deep packet inspection as well. Because a lot of times these phishing attacks are going to be targeting organizations that have what they need. And this is just one of those things. But again, it's been great. Gennaro here, CEO of Koitek Solutions. And we just talked about cybersecurity architecture, brought to you by ACSMI. I do hope you have a great one, and I will see you in the next one. Take care.